Hello everybody. In this class, we will be discussing about a very important topic of Edexcel O-level physics, and the name of the topic is pressure. So first of all, we need to understand actually what do you mean by pressure. So actually pressure means it is the force that is acting on an unit area. Okay. So as you can see here, the definition is given. The pressure is defined as the force acting per unit area. And basically, actually, what do you mean by pressure? So pressure mainly says that how much concentrated a force is, okay? And this is the formula for pressure, where P is equals to force acting on an unit area. And what is the unit of pressure there? The SI unit for pressure is Pascal. And at the same time, we can say that the unit of pressure can be written as Newton per meter squared, because we know that the SI unit for force is Newton and the SI unit for area is meter squared. So now let's deal about some real life examples of pressure. So over here we can see a person is pressing on a block of wood with a finger, and when the same person is pressing on a pin, on a drawing pin over here, then over here we can see the impact of the pressure is much larger than that one. Why this is so? Because we can see here the contact area is pretty much smaller than the contact area of this picture. So if the area where the force is acting is smaller, then the impact of the pressure is much greater. On the other hand, when the area is greater, then the pressure is smaller. Now let's look at another example. Over here, we can see a person is standing on a mattress. So over here, he is lying on the mattress, and over here, he is standing on the same mattress. We can see here, the mattress didn't sink that much, but over here, we can see a considerable sinking of the mattress. Why this is so? This is because of the application of pressure and also the difference in the area. Because as we can see, since the person has lying down over here, so he is consuming a great amount of area. So as we said, as the area increases, the pressure decreases. Whereas the same person is standing over here, the weight remains the same, or we can say the force remains the same. But here, since the area is pretty much smaller, therefore the impact of the pressure is significant. For this reason, we can see here the sinking of the mattress to a significant level. From our discussion, we can draw two graph of the pressure against area. So as we said, that as the area becomes larger, the pressure becomes smaller, and vice versa. So this is the first graph that clarifies what we have just said, that we can see a decreasing curve where as the area increases, the pressure decreases. On the other hand, if we plot a graph of pressure against 1 over area, then over here we can see we are having a straight line that passes through the origin. Whatever we talked about, like that pressure was basically acting on any solid object or any solid surface. Now what if we want to calculate the pressure acting in liquid? So the pressure that acts in liquid is known to be your hydrostatic pressure. So we have a different equation of pressure for this particular formula, and which is H rho G, where H represents the depth of the liquid, the rho represents the density of the liquid, and as we all know that G represents the acceleration due to gravity, which we assume to be 10 meter per second squared. As we can see, we are having water inside a container, and we have made 3 different holes over here from which water can flow out. So as we can see, like this is the surface of the liquid, and from this particular surface, this is the first hole that we have made, this is the second one, and this is the third one. So we can see from the diagram that from the surface of the water, the third one is at the greatest distance, or we can say the third hole is at the greatest depth. So therefore, as we can see, the water is flowing out at the maximum distance in comparison to the first tube. So this is the demonstration actually how we can understand like how pressure depends on the depth of the liquid. These are the two conditions like on which the hydrostatic pressure or the liquid pressure depends on. So the first one is the depth of the liquid and the second one is the density of the liquid. So let me clarify the second one a bit. Let's say we are having demonstration by using water. On the other hand, if we replace the water by mercury, where the density of mercury is around 13 times greater. So in that case, the pressure will be increased as well. Why? Because as you can see from the condition that if the density of the liquid increases, the pressure increases as well. Right now, as I'm standing over here, the air surrounding me is applying a force on my body, whereas that force is being balanced by the blood pressure of my body. All the time we are exposed to the pressure from the air, and that pressure is equivalent to 100 kilopascal. And in order to measure the atmospheric pressure, we have an instrument, and the name of the instrument is called barometer. And it was invented by one of the scientists whose name is Torricelli. He demonstrated an experiment by using a tube containing mercury and a dish containing mercury. When he upturned the tube containing mercury into the dish, he found out the length of the mercury changes. It was the overall setup of Torricelli to make the barometer, or to be more specific, it's the mercury barometer. Why? Because he used mercury over here. So let me explain it once again. So initially, this was the tube. This was the tube. So this tube contained mercury, and over here we can see a dish, and this dish also contained mercury. So what he did was he simply upturned this tube into the dish of mercury, and he found out that the height of the mercury has fallen down, and this much length, this much height of the mercury was found out to be 76 centimeter. When you are converting that 76 centimeter into pressure, you would found out that the value equals to 100 kilopascal. And this is how the mercury barometer was invented. And by using this, we can calculate the atmospheric pressure. Now we will talk about manometer. So what do you understand by manometer? I mean, basically, it's called a U-tube manometer. Why this is so? Because as you can see from here, this shape looks like the English letter U. That's why we're calling this one to be our U-tube manometer. So why do we use this? We use this to find the pressure of a gas supply. So let's understand this one. So initially, as we can see, these two levels contained mercury. I mean, we can say the mercury level of this part and that part are having the same level. So whenever we are adding water on this part, what happens? Due to the pressure of the water, the level of the mercury of this part rises up, and the level of mercury on this part goes down. So this is how it looks like. Now the thing is, as we can see, like there is another concept of pressure. Like when we are at the same horizontal level, the pressure always remains the same. If we see that along this horizontal level, the pressure on this point and at that point is equal to each other. So if I draw it over here, let's say this is point A and this is point B. So as we can see, the pressure at this point is equal to the pressure at that point. Why this is so? Because both of the mercury levels are along the same horizontal level. As long as are there in the same horizontal level, the pressure will always be equal to each other. So we can simply write over here that the pressure at point A is equals to the pressure at point B. Now over here, the source of pressures are different. Why this is so? Because the pressure acting at A is due to two different things. The first one is over here, this end is open to air. So we are having the atmospheric pressure acting on this point. And over here, we have a certain height of mercury. And this end is connected to water. So we can say that the pressure acting at B is only due to the pressure of water. So we can rewrite it in this way, that atmospheric pressure plus the pressure due to this height of liquid. Let's denote this height as H. So we can write that H rho G is equals to pressure due to water. So now if we rewrite this equation once again, so it will be something like this. The pressure due to water is equals to the atmospheric pressure plus the pressure due to the certain height of liquid. So this is how we can use the manometer in order to find the pressure of any gas supply or any other unknown liquid. So that was all about the topic of pressure.